Oracle programs. So Oracle programs, in my humble opinion, are SEDA's greatest USP and arguably the greatest differentiator from traditional oracles, in that the Oracle program is what allows developers to access any of the data, any data that they need from any of the sources from which they require that data. Now, this is different from legacy oracles because they basically hand you a set menu and they say, these are the data feeds that are available on your network. So they're not the full suite of data feeds that they have, potentially. And they say you can have these price feeds or these liquid restaking feeds, and that's about it. Now, if you look at most people's catalogs, there's very limited feeds in the grand scheme of how many feeds you probably need for all the tokens that exist, for all the RWAs that exist, for all the dynamic behaviors that exist, for all the in real life events that exist. There are so many data feeds that need to be coming on chain to really build applications that make sense. Cool. So how do you flip that script? How do you break away from this kind of menu idea like your Chainlinks, Bits, and Redstones do, where they say, here are the feeds that you can access on your network, and that's basically it. Well, SEDA does designed for Oracle programs, which if you've ordered a pizza from, I don't know, Domino's, for example, you essentially will get the gist because you order your pizza based on, this is the base that I want, these are the sauces, these are the toppings, these are how I want it cooked, and this is the address that I want you to deliver it. You pay for it, boom, it happens, and the pizza magically turns up on your doorstep. In the SEDA Oracle programs that live, I actually think they're stored in the WASM library, but we'll draw them here. In your Oracle program, you basically, high level, you define three things: what data you want, which sources you want queried, and how you want it returned. Now, of course, there's actually so much more that you can put into an Oracle program, or custom parameters that you can think of. So, for example, you could build an Oracle program that monitors corporate actions for RWAs, and basically you would scrape a bunch of news sources and they would monitor for news events. And when that news event, such as a stock split, happens, it would go through, it would trigger a request through SEDA, and then it would pass that information to prove a contract, which would trigger a smart contract on a network, which could trigger a dynamic RWA asset to represent the stock split that has taken part in the real life. Just as an example, but basically anything that you can think of can be done, and all the kind of use cases depend on what you're actually trying to do, whether it's with AI, RWAs, DeFi, dynamic LTVs. There's so many things, and they all live on these little Oracle programs here. Cool. So let's expand one of our Oracle programs, and we say Oracle program, which you can define what data, where you want it, how you want it, and then here is like custom parameters, right? So those are kind of like what lives in the Oracle program, and you deploy those to the SEDA chain. And once you have that deployed to the SEDA chain, it lives there, and as a data request comes through that matches the ID of the Oracle program, so your chain and protocol will have its own data request ID, and if that matches the Oracle program, basically that Oracle program is activated to then execute the data request as you had it defined. So this is practice how you flip the script on, these are only feeds that are available, and this is the way that they function. So saying to the developer, you tell me what you want, where you want it, how you want it, and any of the custom parameters, and we'll make sure that your data, your Oracle feed is executed as you need it. And this basically allows developers to create whatever they want, because they can build they can build use cases for applications as opposed to building applications for use cases.